In section P6, we are going to explore rational expressions, and in this video we're going to specifically talk about the domain of rational expressions, and then in future videos we will do basic operations with rational expressions and then simplify them as well. Just to begin with a quick warm-up, I want to review basic operations with just fractions, because fractions really, you can think of them as rational expressions without any variables. So here with multiplication between fractions, with multiplication we want to just multiply the numerator of the first one with the numerator of the second one, so 5 times 3 is 15, and then the denominator we follow a similar pattern and multiply the two denominators together, so I get 15 over 70. And then you can reduce it. I'm not going to take the time to. Now with division, remember what the old rule is that you have to flip the second one and then multiply. So really this is saying this is equivalent to 6/11 times 33 over 12. And if I do that multiplication, well, I can actually do the multiplication, but I can actually simplify here first. So I can reduce these. So 6, there's 1 6 in 6, and then there's 2 6s in 12, and then 11 goes into 33 3 times. So I end up getting 3 halves. Okay, so just a quick reminder on multiplication and division. Addition and subtraction are actually different processes. So what you need to do is look at the least common denominator, or find the least common denominator of the two expressions. So what number has a 3 and 5 in common? Well, that's 15, and then you can certainly go up higher, but 15 is the first one that we encounter. So what we want to do is take the first one and multiply by whatever is needed to get the denominator to 15. So to do that, I have to multiply the denominator by 5, but to keep equality, I also have to do it to the numerator. To this first one, to the second one, sorry, this needs a 3 in the denominator, so I'm going to multiply by 3 up top. Now, this here is a form of 1, so what you want to do is always multiply by a form of 1 to maintain equality. Okay, so if I rewrite this, I do 5 times 7, that's 35 over 15. And then minus, now 4 times 3 is 12, so I have minus 12 over 15. And so now I have the same size pieces, so I can do the subtraction. So I do 35 minus 12, that is 23. Okay, so 23/15. Alright, so that was a basic review of operations with fractions, and now what we're going to do for the rest of this video is talk about domain of a rational expression. Okay, so first of all, let me cover this up. Rational expressions is where you have a polynomial over another polynomial. Okay, and specifically q of x, the polynomial in the denominator, cannot be the 0 polynomial, or just cannot be 0. Okay, mainly because you can't divide by 0. Okay, now the first thing that we have to do with the rational expression is talk about where it exists. So again, in order to have something exist, we can't divide by 0. So what we want to do is locate the places where it is 0 and remove those from our domain. So the domain is the set of numbers that you can put in for x and get out a real value. Okay, so domain of a rational expression is always all real numbers. Okay, and we can use the symbol double bar r if we want. Okay, except, you can use a slash to use except, and then you could actually say the set, and so the curly braces denote the set of numbers, or a set of numbers, and so wherever q of x is equal to 0. Okay, so what we want to do is look at the denominator, find the numbers that make the denominator 0. So in this first part I have x plus 3 and x minus 8. Where does that equal 0? Okay, well, what I want to do is think about, okay, well, what makes this first term 0? Okay, well, that is x is equal to minus 3. Okay, because if I put in minus 3, that's 0, and I get 0 out as a result. And in the second term here, okay, x minus 8, that one, I can't have x is equal to 8. Okay, so the domain here, and I'm going to use D for domain. The domain here is going to be all real numbers, okay, and I'll write this out in a minute. All real numbers except we can't have minus 3 and we can't have 8. Okay, so now again in words I'll write the domain is all real numbers except x is equal to minus 3 and 8. Okay, so first example with domain. Now in our second example here, this isn't in factored form, so what I have to do is actually first I want to see if I can factor. Okay, and then second, what you'll actually need to do is possibly go back and solve an equation. And for this part, you actually want to go into section P7 and look, where we actually solve quadratic and possibly linear equations too. So please take a look at that. But for right now, what we're going to do is most of ours are all going to factor. If for some reason it doesn't, then we can go to step 2. Okay, so what I want to do is I want to try and factor this, and we can factor this by the AC method. I'm going to do this by guessing and checking. So I want to think of what two numbers multiplied to minus 16 but add to positive 6. And so we did this in section P4, P5. And so what we want to do is we recognize that this is going to be a plus 8 and a minus 2. Okay, and so what I'm going to get here for my domain is going to be all real numbers except the set that is positive 2 and minus 8. Okay, so again, just looking at the denominator, you don't have to worry about the numerator at all, and just know that it's going to be all real numbers except whatever makes the denominator 0. Okay, so in this video we did a quick review of multiplying and dividing and adding, subtracting fractions, which we'll come back to in the next video, and then also talked about the domain of rational functions. Stay tuned.